In this video, I want to walk you through two basic examples to think through the application of our equations that we have for calculating the size of static friction. That's friction between two surfaces that are at rest with respect to one another. And kinetic friction, it's the size of friction when two surfaces are actually sliding. So the problem statement is this. A 2 kilogram book is placed on a flat surface and pushed to the right with 5 newtons of force. Let's assume that the coefficient of static friction is 0.3 and the coefficient of kinetic friction is 0.2. And the question we're going to answer is, what's the box's acceleration when we're pushing with 5 newtons of force? Then we're going to find out what's its acceleration if we push with more than double that force, 12 newtons. So if you're pushing with 5 newtons of force, let's make a force diagram for the forces felt by the book, the 2 kilogram book. So we're pushing with 5 newtons to the right. There's going to be some frictional force back to the left. And I guess the question is it static friction or kinetic friction? So when we calculate the size of the force of static friction, it's less than or equal to the coefficient of static friction times the normal force. This is just going to give us a value. In this case, the coefficient of static friction is 0.3, that was given. And for a 2 kilogram object, the force of gravity will be 20 newtons in size pointed downward. So the normal force will be 20 newtons pushing back up. So this equation says that the size of static friction is less than or equal to 6 newtons. It can be smaller than that because if we push with, let's say, 1 newton to the right, static friction will push back with 1 newton to the left. If you push with 2 newtons, it'll push back with 2 newtons. Static friction will always match the applied force up until a certain value. So it can't exceed 6 newtons of force. Well, in this case, we're only pushing with 5 newtons, and so static friction will be pushing back with 5 newtons, and the acceleration of the book will be 0 because it's not going to move anywhere. The sum of the forces will stay 0. So static friction will match the applied force up to a certain value. And if you push with more than that force, then it'll actually start to slide. So that would be the case if we apply 12 newtons of force, which means the book static friction can't keep it in place anymore because that's more than 6 newtons. And so it's going to accelerate. So let's figure out how big of kinetic friction there is when the two things are sliding with respect to one another. So the force of kinetic friction is going to be equal to the coefficient of kinetic friction times the normal force. So that's 0.2 times the normal force of 20 newtons. That's going to give us 4 newtons. Kinetic friction is 4 newtons in size. So while the book is accelerating, if we keep pushing with a constant 12 newtons of force to the right, we've got negative 4 newtons of friction. It's off to the left. We've got our gravitational force of negative 20 newtons and our normal force of 20 newtons. So to find the acceleration, we have to use Newton's second law. The acceleration of an object, in this case the book, is equal to the sum of the forces on that book divided by the mass of the book. And let's find a symbolic expression first for the acceleration, and then we'll plug in our values to get a quantitative answer. So if we add up all the forces in the book, that's technically all 4 of these forces, but the force of gravity and the normal force are equal in size and opposite directions, so they cancel each other out. So the only ones we need to worry about is the size of the pushing force and the frictional force. So it's the sum of the pushing force and the frictional force divided by the mass. And I've got these arrows over the symbol to remind us that when we plug a value in here, we have to decide what the sign is. So these could be positive or negative. If we want a symbolic answer, we're going to assume that we would be plugging in positive values. So we have to decide what the sign of these symbols are. The force of push is in the positive direction, so let's just leave that as a positive symbol. And the frictional force is off to the left, so let's make that minus the size of the frictional force. So if I asked you to find a symbolic expression for the size of the acceleration, it would just be the force of push minus the size of the frictional force divided by the mass of the book. Well, if we want a quantitative answer, let's just plug in our values. The force of push is 12 newtons. We're subtracting the size of the frictional force, that's 4 newtons. So the sum of the forces is 8 newtons, divided by the mass of the book is 2 kilograms. So the acceleration turns out to be 4 meters per second per second. The book would increase its velocity by 4 meters per second for every second that it's increasing its speed. So big picture, if you apply a force on an object that's at rest, the first question is that enough force to overcome the maximum static frictional force? And if so, then you just use the kinetic frictional force while the two surfaces are sliding. I hope that's helpful to help you think about the basic application of our two equations for calculating the size of the frictional force between two objects, either at rest or sliding.